Hi class. In this video, I'm going to show you how to use a website called Data Planet to get some data for finishing the project. I'm going to show two videos, one where I use Data Planet and another where I use a different source. But I think Data Planet is kind of interesting, so let's go there first. Let me share my screen with you so that you can see what I'm doing. I'm going to share my entire desktop because I'm going to be using a lot of different applications. So the first way to find Data Planet is just type Siena College Library Data Planet. And obviously I've done this before. And the first link brings you to the library's data science webpage where they have all kinds of resources for getting data. And one of the first links you'll see here is a link to Data Planet. It takes a while to load, but when it launches, you'll see that on the left-hand side here, there's tons of data that you can select. It shows you data that's in the news, but you can browse by subject area. And each of these subject areas then expands, and you can even select other data. And the hardest part, I think, is going to be just finding things that are interesting. But follow along. I'm going to find two different time series of data, and I'm going to compare them with a scatter plot, and we're going to see if they're connected in any way, if there's any kind of correlation. So the thing that I'm interested in is house price index. And you see you can select all transactions or maybe just house purchases only. I'm going to select all transactions. And then you can see you can select different metro divisions. So you can pick a state like Delaware, and you can pick Wilmington, Delaware, and see it. Or you can pick the entire United States. And you can see that in some cases, you might have seasonally adjusted or non-seasonally adjusted. Right now, the only data set that's available is this non-seasonally adjusted data set. And I want to look at the whole United States. And you can see that this chart, it shows that the housing index is increasing, There's this little bubble here in 2008, and then it decreases, and then it increases and increases. So why this is important to me is I want to use this to see if housing price index, which is basically a measure of how valuable houses are, I want to see if it correlates to something else. So in order to do that, I'm going to export this data, and I'm going to select delimited text. And when I select that, it's going to download it to my downloads folder. And I had previously done this, so I just want to move this to my trash. But when you download a file, notice it's a CSV file. I picked delimited text. And just so that I don't forget what it is, because it just gives it a weird name, I'm just going to call it housing. And I'm going to open it in Excel. So when I open it in Excel, you can see that it's not a very large data set at all. It's only 3 kilobytes, and it has 183 lines of data. And you can see that the first column is the year and the quarter. So this is Q2 of 2020, and you can see this is Q4 of 2018, and I have data going all the way back to 1975. So that's very interesting, and I just opened in Excel to look at it closely, but we're actually going to open this in Colab and manipulate it in Colab. But now I want to compare this housing data to see if it's connected to anything else. And a hypothesis that people have is that a lot of the wealth in this country, in the United States and the USA, is connected to people's homes. And the Dow Jones Industrial Average is an average of all of these large companies and how well they're doing. And my hypothesis is that these two things are highly correlated. I don't think there's a dependent one and an independent one. I just think both of these things are an indicator of the strength of our economy and the strength of the dollar. So I'm going to just see if they're correlated and see if there's something that's interesting. And what you can see here is that this is the Dow Industrial Average of the US. And I'm going to export it and download it again. Delimited text. It goes to my downloads folder. And I'm going to rename this Dow, just to show you. So these are right now in my downloads folder. You can see the Dow is much bigger. It's a much larger data set. And the reason why it's a much larger data set, let me load it up so you can see, is that the value is computed every day. So you can see this is 2020, this is November 9th, this is November 6th, this is November 5th. This industrial average is not calculated on weekends, so it's not calculated on Saturday and Sunday. And it's not calculated on holidays like New Year's and Christmas and things like that. But it's interesting data. And the question is, are these two numbers correlated? So to do that, I'm going to import both of these into Colab, but I'm going to do it following best practices. So the next thing that I'm going to do is I'm going to go to GitHub. So if you Google GitHub, it should bring you to GitHub. Now, I already logged into GitHub. You should have a GitHub account. And if you haven't already, you can create a new repository for this course. I created a repository for this course, and I can add files. So there's a button here where I can upload files, and then I can browse my computer, and I can browse my computer for these two CSV files that I downloaded. I click open, and in GitHub, you have to commit these changes. So this will finalize the upload. And you'll see in a second that both of these files are now available on GitHub. And if I scroll down, you'll see here's the file DAO and here's the file housing. And I'm going to click on the file DAO, and I'm going to show you. When I click on it, it's a small enough file that it displays it. But there's a button here to view the raw data. And if I view the raw data, this is actually a hyperlink to the raw file. This is a file that I could download into Colab. So what I'm actually going to do is I'm going to highlight it and I'm going to copy it. So I'm going to click right mouse click and click copy so that I have it. And the next thing that I'm going to do is I'm going to open up a new Colab notebook. And the way to do that is I've got to log into Google, which I'm already logged in. And you can click new. And if you click more, there's all different types of Google Docs you can open. And I'm going to open a Google Colab file. And the first thing I'm going to do is I'm going to give this a name. And this is going to be project warm up, or maybe project draft. And one of the things that's really going to help me is if I bring up files that I've already created. And the things that we did in class were quite relevant. So I've shared with you the solution to the week 4. And the solution to week 4 is very great because it shows you all the code that we need in order to start a data science experiment. And one of the first things we have to do is import some data. So I'm going to move that over to my new file. Just bear with me. And I'm going to run it. So I just imported all of my files. And then the next thing that I'm going to do is, this is the code to read in a file. And it's actually this right here. And sadly, I copied a little bit too early. If I go back to GitHub, this is the URL of where that DAO data resides. So again, I'm going to copy it, and I'm going to replace that with the URL. I'm going to put it in quotes. And the other thing that I'm going to do here is I'm going to give it a more descriptive name. I'm going to download or load up 2 different data sets. So I'm going to call this one DAO. And again, the last line of a Colab cell, it'll output whatever that is. So I'm going to output DAO. And you can see what it does. It indicates the time column, and it indicates this other column. This other column is very, very wordy. And the thing that I don't like about that is later I want to refer to this column, and I don't want to have to type that every time. So one of the things that I can show you, which is kind of nice, is over in GitHub, that's where this file resides. And I can change it if I want. There's a little edit button here. It's this little pencil button. I can click edit, and I can edit this raw file. And instead of calling this Dow Jones Industrial Average, Close International, whatever, I'm just going to call it DAO for short, so I can type it real easily. And after you make a change like this, you have to scroll down and you have to commit your changes. Now, it takes a while for this to happen, right? Right now, this is being saved on the cloud. And if I go back to my project draft, and if I click play, it may take a while for this to change. So right now, I'm just going to leave it, but eventually, this should change to the shortened name. But what I'm going to do now is I'm going to kind of continue. And one of the things that is interesting here is for the DAO, I have a year, a month, and a day. But for the housing data, I have a year and a quarter. And what I'm going to do is to kind of simplify things, I'm going to look at how things change every year. I'm not going to look every quarter or every day. I'm going to look at every year. And you'll see why. It's a little bit easier. So to do this, I have to break up that time into its three components: year, month, and date. And what I'm going to do here is I'm going to cut and paste some code, but here's how I did this. I researched how to break a column into different parts in Python. And this is very specific to a pandas data frame. What I'm looking at right now is a pandas data frame. So I Googled pandas data frame, how to separate a column into different values. And what I did is I found some code to do it, and I'm going to show you that code here. Now, I'm going to add this code to another block. So let me just do this really quick. And when I did this before, I called it DJ for Dow Jones, but now I'm going to call it Dow. Notice everywhere where I have DJ, I'm adding Dow. Now you might find code where it refers to the data frame as DF. So what I'm doing here is I'm changing it to Dow. And then what I'm going to do is I'm going to output Dow to see how it's changed. Now I want to explain what this is doing. This first line of code is converting that time to make sure it's a string so that I can grab it character by character. This is a function map, which will take the first 4 characters and map it to year. It'll then take characters 4 through 6 and map it to month, and then it'll do characters 6 through 8 and map them to day. Remember, we start with index 0, and this means we go up to 4, but we don't include 4. So what we're really doing here is we're grabbing index 0, 1, 2, and 3. And we're grabbing those 4 characters, and we're creating a new column called year. We're doing the same thing, and we're creating a new column called month and a new column called day. And if I do that, what you'll see now is that year, month, and day are now broken up into their components, which is going to help us do some more analysis. This is what's called data cleaning. A lot of times you get a data source and it isn't quite right. You need to manipulate it in some way. And now I want to see, I'm going to hit play again. And I'm still not sure why. I changed Dow so that this was abbreviated to Dow. I think it just takes a while for it to change on the cloud. I think eventually it will change. I'm going to just play it one more time to see if it finally changes. Boom, there it finally changed. So now when I do this, it's really nice. You can see this is the time field, this is the Dow value, this is the year, the month, and the day. Now, the thing that's interesting is that I want to compare this with the housing data. So I'm going to do exactly the same thing that I did here, except the only thing that I'm going to do is I'm going to create a new data frame called housing. And if I go back to GitHub, and if I remember what I called it, boom, I called it housing. So I'm going to come back here and notice this URL. It's where GitHub stores user data. There's my user account. There's my repository. And instead of Dow, it's going to be called housing. And again, I'm calling the data frame housing. And again, to make sure I'm doing it correctly, I'm going to output housing. And you can see there again, the column header is just so long. So I'm going to go to housing. I'm going to click on this little pencil button, and I'm going to just change this from this long thing to housing. And again, in GitHub, every time you make a change, you have to commit those changes, and it probably will take a few minutes for that to take effect. So coming back to this, I'm now going to use this code, and I'm going to do the same thing for housing. But notice that housing doesn't have a day and a month. It has a year, and then it has a quarter. So what we're going to do is we're going to break it up as follows. I'm going to use this code as a model, and I'm going to create another code block here. But now instead of Dow, it's housing. And so I'm going to replace that in these 6 instances. And now instead of having a year and a month, I have a year and a quarter. This is like a financial quarter. 0 to 4 is still the year, but now it's actually 4 to 5 is just a quarter. So this would start at position 4 and it would stop before you hit position 5. And you can see, why is that the case? Well, if I come here, the first 4 characters are the year and the 5th character is the quarter. And the quarter is just 1 digit. So if I do that, then the next thing I can do is I can output housing. And you can see here is the housing data broken up by year and broken up by quarter. Now, in order to compare this, I've got one data set that is based on month and day, and I have another data set that's based on quarter. The thing that they have in common is that every year we have a value. And so I'm going to group by year, and I'm going to compute the average or the mean for each year. So, but again, I want to note that if I rerun this, I'm going to re-grab the housing data, and eventually this index will change to something shorter. It'll be housing instead of that big long text string. So that should happen soon. So in order to group, again, this is going to require some research. I did a Google search on pandas data frames, and I said, how do you group by something like year or group something by month? And I found an example. And sometimes finding an example, the example won't work and you have to experiment with it. So I went through the process of doing that, and you're gonna have to go through that process. But I just wanna show you it working. So what I'm gonna do now is, I just wanna show you. I'm gonna take, this is the code that I have that I know works. And I'm gonna do housing first. So I'm taking the housing data frame and I'm grouping by year. And for all of the rows that have the same year, I'm going to compute the mean. So for housing, I'm going to take the average of the 4 quarters, and I'm going to say that that represents the year. And I'm going to call this housing grouped. And again, I want to output it so that you can see it. And now you can see we have this very complicated data set. It's not that complicated. So what's the year? Oh, the problem is I don't have year yet. Group by year. Here's year. Maybe I need to run this one more time. I see year, group by year, mean. Let's see, there's no housing. Okay, I'm sorry. It was a little hiccup. I just needed to run the code. So now what you see here is for every year, we have the mean value. And you can see going back to 1975, that mean value was very low, and it increases and increases. And by the year 2020, it's pretty high. So I'm going to do the same thing, exactly the same thing for Dow. So I'm going to copy this code. And hopefully at this point, right, you realize that this is the name of the data frame. This is the method that groups by. I'm grouping by year. And I'm copying it to a new data frame called Dow grouped. And again, I'm not expecting you to do this in real time. I'm expecting you to pause this. And now, again, it runs into the problem. And I think it's because I just have to rerun this code. Let me run it. I can see there's Dow, and there's year, definitely has a year. And then if I run this again, hopefully it'll work. Yep. So sometimes you just have to rerun a block of code earlier to kind of reset things. So now I have housing grouped and Dow grouped. And the commonality is they both have an index year, and they both have a value that's associated with that year. So the next thing I'm going to do, and this is something that's important, is I want to make sure the housing is now simplified. Yep, there's housing. It's got a simple column header. I'm going to rerun this code to get the Dow. Now you can see the Dow has a simple column header. Then I'm going to do the same thing with housing. Again, simple column header. And then here is the Dow grouped. And if I change that to housing group, just output it here, change that to housing group, you can see there's housing group. Now, the last thing that I'm going to do to finally get this data ready to actually do a plot is I'm going to combine these. And the commonality is they both have the same index year. So again, I Googled Pandas data frame, how to combine two data frames that have the same index. The index is basically the label for each row. And I was able to find the code to do that. And the code for doing that looks like this. And here's where I'm going to kind of break it down a little bit. Right? PD is the name of the pandas library. Concatenate is the name of the method. Concatenate takes two arguments. The first argument is the set of data frames we want to combine. We want to combine housing grouped with Dow grouped. Now, what axis 1 means is that data can be multidimensional. And axis 1 means combine these based on the common, one-dimensional index that we have, which is the year. And so when I do this, it's going to create a new data frame called DF, which I'm going to print here, and you'll see it. The new data frame couldn't be any simpler. It shows the housing index, it shows the Dow Jones index for each year. And you can see that the housing index goes back to 1975, but the Dow only goes back to 1980. So this is a flaw in the data set that I got. Maybe if I got a different data set, I could get the Dow going back further. I don't know, maybe the Dow started in 1980. I'm not a subject area expert, so I don't know. But we do have many, many years where we can do a comparison. And again, I can go to chapter 4, the solution. And the thing that I'm interested in looking at are scatter plots. So here's the solution to the first scatter plot. And I can take this code and modify it. And I've already done this, and I want to show you this real quick. And by the way, I'm going to share this with you in class. So I'm going to create another code cell, and this is going to output, I just need to show it. This is going to output the scatter plot of the data, and it did not work. And I'm trying to figure out why. Oh, I know why. Because this is called Dow, and this is called housing. There it is. So when I did this beforehand, I called this Dow Jones and I called this housing price. But in a simplified example, I just made these column headers be very, very simple one-word descriptors. And you can see I'm adding the X label, I'm adding the Y label. This scatter plot is a method that takes two parameters. This is the thing you want to plot on the X-axis. This is the thing you want to plot on the Y-axis. This is an optional parameter where I want to make this green. I could change this to blue and it would be blue. And this is what the scatter plot looks like. And the scatter plot to me, this is an intro class. When you take intro to data mathematics, when you take machine learning, you learn more about what it means for data to be linearly correlated. But I think you can visually see that there's a pattern here, right? That as the Dow Jones increases, the housing index increases. But then there's some insane stuff happening here. But then the pattern continues. As the Dow increases, housing increases. This is a case of where this shows me that there's a pattern. But this is something I wouldn't expect you to do, but it's something where I can show you the power of programming, where this would be very, very difficult to do in Excel for a large data set. I'm going to add a for loop. And this for loop, I'm going to stick it right here. This for loop iterates over the rows of the data frame. It grabs the index, which is the year, and it grabs the value, which is the Dow Jones and the house price. And what it does is it adds a text annotation to the axis of this plot. This breaks the plot up into a figure and an axis. And on the axis, we can add a text annotation. And I'm going to add the index, which is the year, and I'm going to use the V to position it. So I'm going to position this label right where the dot is. So when I run this, it takes a while because it's pretty computationally intense. Actually, I don't know why. Oh, boy. Oh, there it is. Nope, that's not it. I can't believe this isn't going to work. This worked so nice before. I'm just trying to figure out what might be the problem. I feel like Colab crashed. I just got this working. So let me pause my video and let me come back and see what is wrong. All right, I was able to figure out the problem, and so it finally worked. The problem was solved by I did a factory reset runtime and I ran it all. So the thing to consider sometimes is with this is one big program where there are dependencies, and when I was playing around up above, I might have changed something so that this code doesn't work unless I rerun it from scratch. So I did that, and here's what it ends up showing us. And what I think is so interesting about this is that, and I realize I have the axes mislabeled, which is so silly. I'm so sorry. I'm going to change this to the y-axis and this to the x-axis, and then I'll rerun it, and then it'll be correct. So this is the house price index, and this is the Dow Jones. And what's so interesting is you can see what happened. As the house price index went up, the Dow Jones went up. So there's kind of like maybe like a curved relationship. And then something weird happened here. So to kind of show you what happened here, back in 2000, the Dow Jones was at about 10,000 and the house price index was at about 250. And then as time went on, the Dow Jones actually started to go down, yet the house price indexes went up. So in 2001, 2003, you can see the house price index went up. And the house price index went up all the way to here, all the way almost to 400. But the Dow Jones wasn't increasing that much. And this represented this housing bubble where the prices of houses didn't really reflect the economic prosperity. And then what happened was, you can see in 2009, the Dow Jones crashed and the housing prices crashed. But then you can see the Dow Jones starts lifting up, but the housing index goes down. And then it took almost until 2012 till there was a recovery, and then it returned to this kind of linear increase. So what you're actually seeing here is you're seeing basically a linear increase with this weird loop. And this weird loop represents anomalies. It represents that the housing index prices were kind of out of whack. So let me kind of come back to the big picture here. Think about what we did. I grabbed 2 time series data sets from Data Planet. I put them on GitHub. I imported them into Colab. I modified them by doing some heavy researching on how to group by and how to separate the time into a year and a month. And then I concatenated them together, and all of this code I'm going to share with you. But this is an example of something you can do. And the hardest part, I think, is finding a good set of data. And then the hard part is doing the research to figure out how to get the data in a usable format where you can plot it. And so this is an example of something that this alone would earn a respectable grade. This might be close to an A. I think what would be more interesting is I only picked 2 time series. It'd be interesting to pick 3 or 4 and to intercompare them all. So once you sort of perfect this, I can change it. So instead of looking at Dow and housing, I could look at Dow and manufacturing. I could look at housing and manufacturing. So once you sort of have this framework working, it becomes super easy to import additional data sets and to create not just one scatter plot, but if I have 3, different data sets, I can intercompare all 3 and I could create, several different scatter plots. And then later I'm going to show you how we can import these into a poster. And then that poster basically becomes the final deliverable of this project. So let me shut up and go, and I will see you in class.